Hi everybody. Last section we worked on the vertex form of quadratic equations and how it told us where our vertex was and our axis of symmetry and whether they opened up or down and our domain and range and all of that from vertex form. It just gave it to us. This doesn't always happen. You could have a quadratic equation in what's called standard form. Standard form looks like this. So it's the function is something x squared plus bx plus c. A, b, and c are the what it could be, all different kinds of numbers. In this case, the vertex is kind of a little hidden, but you can still find it. So there's some tricks to know that will help you to find it. There's a big mathematical formula for why this works, but I will just tell you what to do, okay? And how this will work for any type of equations. All right, the a is always the coefficient in front of the x squared. That's important. The b is always the coefficient of just the single x, and the c is your constant. So we're going to use the a, b, and c for all. When I refer to a, b, and c, I'm always talking about those, no matter what order they're in. What you want to know is how to find the axis of symmetry. This needs to be memorized. It needs to be in your notes. The axis of symmetry is negative b over 2a. Negative b. So whatever this number, this coefficient of the x, change its sign. If it's negative, it becomes positive. If it's positive, it becomes negative. That's what this means. Change its sign. Put it over 2 times whatever your a is. That is your axis of symmetry. That's the line that goes straight up and down right through the middle of your parabola. By the way, that's also the x of your vertex, right? The axis of symmetry is the same as your the x of your vertex. So once you have that value, you can plug that in for x and then solve this to find y, and that'll give you your y of your vertex. Okay, so now you have your whole vertex by doing that. So this negative b over 2a is really, really important. If this a is positive, your parabola opens up. If this a is negative, your parabola opens down. And that way you can tell, does this have a maximum or a minimum, and what that is. So let's walk through this so you can see what it looks like. So here's our first quadratic. Y equals negative 3x squared minus 4x plus 6. And our a then is negative 3. This is step number 1, is being able to identify. Our a is negative 3, our b is negative 4, and our c is 6. So once we know those numbers, now we are going to do the negative b over 2a. So if b is negative 4, negative b is positive 4. So that's 4 over 2a. A is negative 3, so 2 times negative 3 is negative 6. And there is our axis of symmetry, which is x equals negative 2/3. That's what we get for this. Now, we need to plug that in to see what our y of our vertex is, because this is the x of our vertex, negative 2/3. And it doesn't look like I picked a fun one for our first example, but that's okay. We need to do these too. So we're going to go back here, and we're going to plug that into this. So we have negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6. So that's what we need to do. This squared becomes positive 4/9. So negative 3 times 4/9 is 12/9 or negative 4/3. Right? We good with this? Negative 4/3. And this becomes positive 8/3 and plus 6. Right. Okay, so negative 4/3 and positive 8/3 is 4/3 plus 6. So that looks like it's 7 1/3. You can leave that as 7 1/3 if you want, or you can make it an improper fraction if you want. I'll just write 7 1/3. You could make it 22/3, whatever. There's your vertex. Crazy. All right, our a is negative. which means this parabola opens down. Therefore, it has a maximum, right? So if we're asked for the domain and the range, the domain is all real numbers, just like before, still left to right goes on forever, but it has a maximum because this is negative. And the maximum is, the maximum is 7 1/3. So our range is y is less than or equal to 7 1/3 because it's our maximum. So when we plot this, when we graph it, our parabola will open down and our y's are everything from 7 1/3 down below. Okay, that's our range. The other thing that standard equation shows you, which is really cool, is this number right here, c. C is your y-intercept. So if this is your y-intercept, if we plot this, we could do that point, negative 2/3 and up to 7 1/3, and we already know it crosses the y-axis at 6, so we have 1 point, and plot that point, and that'll give you your parabola from there, which is, that's really helpful. So that's our first example. Let's say we're given this and we are asked to graph it. So what we do is we go through the same process. Notice our a now is a 1. Don't think that you don't have an a. If you have just the x squared and there's no number there, you have 1x squared. So it is a 1 is a. B is positive 2, C is 3. So we're going to do our negative B over 2a that you have so memorized and you're not going to forget. B is 2, so that's negative 2 over 2 times 1, or positive 2. So x equals negative 1 is our axis of symmetry. So if we already started to graph this, we know our parabola is that's going to be right down the middle of our parabola, negative 1. Do you see that? So now we're going to make x negative 1 to see what the y of our vertex is. So if I make x negative 1, negative 1, let me just write it out. Negative 1 squared plus 2 times negative 1 plus 3. So this is 1, this is negative 2, positive 3. So it looks like our y is 2. So our vertex is negative 1, 2. There's our vertex. And we plot that point. And our y-intercept is 3. That's handy. So we plot that and we reflect it on the other side. And there's our graph. And that's all there was to it. Having that y-intercept really helped, didn't it? Let's walk through another one. Now that you've seen how it works, I have y equals negative 2x squared plus 2x minus 5, and we're going to graph this one. Notice this is negative, so this one should open downward. And the first thing we want to do is find that axis of symmetry, so we're going to go negative b, which would be negative 2, over 2 times negative 2, or negative 4. So our axis of symmetry is positive 1/2. So x equals 1/2. That's our axis of symmetry. So if this is 1, here's our axis of symmetry, just to help. All right, plug that in for x to find our y of our vertex. So we're going to make our x 1/2. So negative 2 times 1/2 squared plus 2 times 1/2 minus 5. 1/2 squared is 1/4. So negative 2 times 1/4 is negative 2/4, or negative 1/2. And this is 1 plus 1 minus 5. So this becomes, it looks like negative 4.5. Negative 4.5. So our ordered pair is 1/2 and negative 4.5. 1, 2, 3, 4. There we go. And our y-intercept is negative 5, which would be here, which shows that it opens downward. which is what we would expect because our A is negative. And there we go. We just graphed it. Sweet. And we only found 1 point. That's enough to get the general shape of the graph. And it's definitely enough to do the online graphing, because all you need is one other point besides the vertex. Okay, let's add another challenge. Let's say we have our quadratic y in standard form, 2x squared plus 10x plus 7, and now they ask you to change it into vertex form. So let me remind you what vertex form looks like. All right, there's vertex form written up above, and we have some letters that we need to figure out. We have A, and we have H, and we have K. But wait a minute, we have A. Is that the same as this A? Yes, we already know this. So all we have to find is HK. Isn't that the exact same thing we've been doing when we've been looking for the vertex? Yeah. H is negative B over 2A. So let's do negative B over 2A. Negative B is negative 10 over 2A. 2 times 2 is 4. So what we have is negative 5 over 2, or negative 2.5. Negative 2.5 is our H. That's our X of our vertex. So what we're going to do is we're going to plug that in order to find our Y. And you can use your calculator for this if you need to. So we have 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. And we figure all that out on our calculator. And when we do, we get negative 5.5. So there's our Y of our vertex, negative 5.5. And I think we have everything we need. Just plug all that information into here. So we have Y equals, our A is 2. This is X minus a negative 2.5 squared, right? Plus a negative or minus 5.5. By the way, if you put plus negative 5.5, that's perfectly fine. Right? And there we have it. There it is in vertex form. Pretty sweet, not too difficult to do at all. I hope you got that, because your lesson check question for this section is this standard form. I want you to change that to vertex form. So if I have negative x squared plus 4x minus 5, what would this be in vertex form? So find your A, find your HK, and plug all that in, and you're good to go. Okay, let's apply this type of situation, Let's apply it to real life. This is the example that is in your book. We have a road that's crossing a river gorge. And supporting that road is this arch that's anchored into the banks alongside this gorge right here. So they've constructed an arch which supports that road. By the way, the arch is in the shape of a parabola. And this equation represents this arch. Now the foundations for our arch are written 516 feet, or not written, but driven in, anchored, 516 feet above the bottom of the gorge. So our question is, how high above the bottom of the gorge is the top of this arch, and how wide is this section of road that is above the arch? And that's what we're asked to find out. And you might think, how am I supposed to find that? Well, here's how you do it. You think of this as a graph. Notice our y-intercept is 0. So on a graph, this would be 0 right here. So if you think of a graph, this is 0, 0 right here. And what we want to find is the vertex here. Now that vertex will give you how much distance this is from here to here. That's what the y of your vertex will tell you. You add that to 516 feet, that'll tell you how high the whole thing is above the gorge. Also, this vertex, remember that this is an axis of symmetry, which divides it exactly in half. So when we find the x of this vertex, we're halfway to the other end. So whatever this distance is, double that, and that will give you the amount of road above the arch. If you're confused, let's walk through it. And we start with negative b over 2a. So you're going to need your calculators. So negative 0.847 over 2 times negative 0.000498. And you put that in your calculator. Be careful that if you put that in your calculator and you go this divided by this, and then you put parentheses in that, your calculator may do order of operations. It's kind of smart. And if it does that, it'll go this divided by this, and then it'll multiply that answer by this, and that's not what you want. So you would put all of this in brackets, okay? So go negative 0.847 divided by, and then parentheses, 2 times negative blah, 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 blah. All right, and that will give you your A, or your X of your vertex, your axis of symmetry. So enter that in. What do you get? Your calculator should have told you 850. X is 850, or something very, very close. So that's the X of our vertex. Now we want to find this height. So what we're going to do is we're going to make this 850 and that 850. So 850 squared with your calculator, multiply by this number, don't forget the negative, plus 850 times that equals, that'll give you this height right here. So what did you get? You should have gotten 360 feet. All right, so your vertex then is 850, 360, and those are rounded numbers, which is fine. And now that means to find the entire height from the bottom of the gorge to the top, or to the road, you would go 360 plus 516. Don't forget that. So that would be what, 876? 876 feet would be the answer to the first question. Then the second question was, what's the span of road that covers this arch? So it's the entire arch. And if halfway across is 850, then you have to go 850 plus another 850 to get the entire distance of 1,700 feet. Okay, that's how you would apply this in this real life situation. I hope that made sense to you. That's the last thing I'm going to show you, and you know we'll be able to practice this in class. So I will see you guys again next time, and have fun with standard form.